Yeah, can you see my screen?
Yes, ma'am.
Okay, thank you. Just a second. Okay. So, today it's the second live session for basic environmental engineering, pollution and abatement. And in the last class, we had learned the basics and basic terminology behind, like related to environment, like for instance, ecosystem and some other pollution terms, like why do we need to study this course and how there could be some chances of pollution and what sort of contaminants are there. So maybe in this class we will start with next uh, like from this session we will be starting on different concepts. Like we have studied the basics of environment and various terminologies related to it. Now we will be studying how this environment is getting contaminated. For in the last week, we had listed few examples on how it is happening, and so now we will have a detailed discussion on what is its origin, how different we had seen that there is a biosphere in which we live. So there is atmosphere, there is lithosphere. So how all those components on the globe they are getting affected and they are getting polluted. So first and foremost terminology which we all are aware these days is the pollution, right? So if we want to define what is pollution, then like every now and then we use term pollution, but what is it, how it arises, and what are its threatening impacts. So that all we need to learn, and what science is there behind, like why it is giving harmful impacts. So that all we need to understand. So from now onwards, we will be looking at that perspective. So starting with the terminology, pollution. So pollution is nothing but introduction of any harmful contaminants or materials. It can be harmful to the natural environment. It can create a damage to it, uh, or it can have some harmful impacts on the human or maybe other living organisms later. So, such entrance of or the entry of harmful contaminants in the natural environment that can have some adverse impacts is known as pollution. Now, it can have various ways, like it can have a chemical form which can enter into air, or it can enter into water, or it can be in some energy form. For example, it can be noise, it can be heat or light as well. Now, this pollution can arise from various activities. Now, this activities can be like it can naturally occur due to some natural phenomenon as well. This, like we had discussed or we had listed last week. So here again, if we see the naturally occurring phenomena which results into some sort of pollution, it can be volcanic eruptions, it can be forest fire. Now, if we take example of forest fire, then you see entire forest is under fire. So there is a high risk that due to burning of plants and trees, there will be large amount of imbalance in these gases generated. Okay, so there will be a lot of burning of carbonaceous material will be there due to forest fire. So a lot of CO2 will be generated and other pollutants in the form of gaseous. There will be lot of ash generation. Further, there will be a rise in temperature of the surrounding as well because fire has generated. So those are nothing but some sort of pollution because whatever naturally occurring natural characteristics of environment are there, they are getting changed. Then other type of pollution that can arise is due to man-made activities that could be some domestic, commercial or industrial activities. Right. So there could be some waste we are generating from the houses, waste from the industries. They all tend to uh, have some different impacts. It can be of different types. So if we look into the phase of what, for example, if some waste is generated from the houses, then it can be solid or liquid. So depending on the phase of the waste which is generated and the pollutant, it can be classified into gaseous pollutant, liquid pollutant, and solid pollutant. And also, for example, gaseous pollutant, it has the tendency to pollute air. Liquid pollutant, it majorly pollutes water because we directly dump, or if it is treated, then there are chances that water bodies get polluted. And whatever the solid content is there, it has chances of pollution of water if we dump it in water, or it has chances to pollute soil as well. So now, if we talk about the pollution, then depending on the source, then there are chances that there could be a point source or there could be a non-point source. Now, if we define these two terms, then point source is nothing but we are able to find out or we are able to define its origin. For example, pollution or wastewater stream which is coming from an industry. So you know that from this point, particular point, this stream is originating and which is further spreading pollution. So you know the origin of such pollution source. In that case, it is known as a point source. Now, in some cases, you do not have any idea from where it is generated. Okay, so for example, once the wastewater stream is mixed into the river, and now that river flows and it again merges with another river and ocean maybe. So here there is chance that there are the you cannot say that it is generated from this point, right? So in that case, it is non-point source. Now, if we talk about the impacts of pollution, then there are different impacts like it will have negative impacts on environment. For example, it was shown in the lecture that there could be some aesthetically aesthetic degradation. For example, Taj Mahal, its surface got uh, damaged, right? Or like there was a change in the color of the marble used. Now that is because of the deposition on the surface, right? So that is nothing but because of the pollution. Further, there are a lot of diseases which are spreading, right? So for that, how the pollution spreads, like here we have termed that it's originated, but we need to understand how it is spreading through these mediums, through air, through water, or through soil. How it is spreading? So there are various ways through which it can spread or it can reduce the impact. So for that, there are four terminologies. First is dispersion. So once, let's say for example, uh, there is a vehicle from which this is its exhaust. Now, there will be some gases which are emitted. Okay. Now, this gases, it will not obviously stay at one point and it will remain there. What is the tendency of gas? Gas is always lighter and it tends to move up in the upward direction. Now, and this Also, it depends on the wind velocity. So this transmittance of gas pollutants, we will look further into in detail in the next slides. But for now, you can say that gases will diffuse, like it will travel from one place to another based on the density difference, based on the concentration difference. So dispersion will occur. Now further there could be some, so you can say, so gases has dispersed and obviously its concentration, so whatever is released it will get reduced because it has traveled in different directions. So if you it at this point concentration will be, let's say Ci, and here it's C, then obviously Ci will be greater than C. So at longer distances obviously its impact will be lesser. The next term is dilution, right? Say, for example, there is a river stream which is contaminated with, say, for example, lead. Now, river has the tendency to mix, right? Okay, so there are rivers which come across and they mix, and after that junction, mixture, like again, that mixture river will flow. So here there are two streams. One is non-polluted. It does not have any concentration of lead. Now another river comes which has Pb in it. So you can say the one which is going, like which is a mix of both, then it will have a diluted because the one which is not having lead and one which is having lead. So you are mixing both and hence the concentration reduces. Now, another way of uh, doing or reduction or minimizing the impacts are deposition. For example, there are pollutants in the river stream, and there could be some rocks which are coming in on its way. So it might hinder its path, and there are some pollutants which has ability to interact with that. So there could be some chemical interaction or there could be some deposition in the form of precipitates. So that is nothing but deposition. So its mobility is reduced and hence you can say its impact can be lowered by deposition because it will not further travel and it will not come into your contact so that it can further be cause an harmful impact. And last term is degradation. So, for example, there are various organic contaminants which are coming in water, and if they are getting degraded, then obviously its impacts are reduced. So, degradation can also reduce the impacts of pollution. Is it clear till now? I request somebody should answer whenever I ask so that I get to know whether we are uh, following or not. Yeah. So let's move forward. Now, once the pollution has entered, so we will define different types of pollution. So it can we can have pollution of water, we can have pollution of air, or we can have soil pollution, noise pollution, right? So let's define or like how these pollutions or by what uh, pollutants water gets polluted or air gets polluted, and what are the uh, common pollutants which are present in these water bodies or air. Okay. So now, if we talk about water pollution, then it is caused by, like say for example, you have a pure water body. Now, due to the presence of some like excess material or pollutant which can cause harm, so it can be due to some, uh, say for example, it can cause variation in the temperature of water body. Okay, it can cause variation in the uh, suspended particles, right? So all these type of pollutants they come in the physical it due to some physical substance, okay? And here some change in temperature or some visual impacts, like for example some color also, water changes its color, okay? So some aesthetic difference you are able to see, so physically you are able to feel or see the changes in the quality of water. Now next is due to the presence of chemicals in the water. So maybe you are able to see through your eyes or not. There are some chemicals which are very hazardous and they have tendency to impact your health adversely. Such chemicals include BOD, COD, then some heavy metals, right? Now there could be some microorganisms also, which are comes under the category of biological pollutants. Say for example, some bacteria, some viruses, if they are present, then it has the tendency to uh, spread some disease, right? So all these affect the quality of water and they are capable of harming living organisms, right? So some of the major contributions come from rain leachate. There could be some oil spill. There could be some domestic wastewater, for example, toilet, the waste water which is coming out of bathrooms after washing your clothes. So all such sort of water which is coming from your household purposes, it comes under domestic wastewater. And obviously industrial wastewater, where after the uh, processes going on in industries, there is a lot of wastewater which is generated, which can have higher temperatures, which can have uh, high concentrations of chemical in the form of all these suspended particles. Also, it will have high BOD, COD. It can have heavy metals. It can have much more complex chemicals. Okay, so such wastewater also pollutes, causes water body pollution. Now, further, there is, if we talk about air pollution, then air pollution can be due to the presence of some abnormal amounts of chemical constituents in air, which could be in various phases. For example, if there are some various harmful gases present, it could be because of carbon monoxide and carbon dioxide, NOx, SOx, etc. Now, this could arise from industrial activities. Say, for example, you have a power plant where you are generating electricity from coal. So, coal to electricity, this is the target. Now, but this coal has some sulfur, some nitrogen will also be there, and obviously the combustion of coal will result into carbon monoxide and dioxide depending on complete and partial combustion. Further, there will be vehicles which will release these gases, which end up into air and it will cause pollution. Now, further particulate matter. Say, for example, there are dust particles, there are fly ash. So, all sort of such sort of solid or maybe some liquid droplets also, which can cause aerosol present in air, it can cause uh, pollution. So particulate matter, if we talk about, then these are some small fine particles which are present in air, right? And depending on the size, it can have different impacts on our human body. Say, for example, if we are inhaling air which is having dust, it can immediately cause you cough, right? And it can even affect your lungs. So it depends on size, how it will impact. So depending on the size, PM 2.5 is the one which has two particles which are smaller than 2.5 micron. PM10 is the particles having sizes average of 10 micron, right? So 10 micron particles obviously will not be able to enter our body, and hence it has lesser impact. While PM 2.5, it stays in the lungs of our body, and hence PM 2.5, it impacts our body greatest. Okay, it has the highest impact. Now, next, if we talk about soil pollution, then it is obviously related to the water pollution, and it is the degradation in the quality of soil. Now, how it is related to water pollution? Because water bodies, so water from the water bodies, it has the tendency to go into the ground. So water will percolate through the soil, and if the water is itself polluted, so what it will cause, let's say there is arsenic or lead which is present in water. Now that water which is polluted, it enters or percolates in the soil. Now this creates pollution in soil, right? So how it spreads further through the cycles or food chain that we had learned in the previous class. So that was our basic aim, because whatever the pollution it enters in one form, it has the tendency to pass on further through different chains and majorly through food chain. Okay, so everything is linked. So pollution, once it has entered in soil, it can be taken up by plants, and now these plants will be consumed by firstly primary consumer, then secondary consumer, tertiary consumer. So and so on, it will pass on through food chain and create its negative impacts. Okay, it will have its negative impacts by the consumption. So by this way, through food chain, it will pass on. Now, once we have learned the pollution in like what sort of pollution can happen. Industries are the major cause of pollution if we talk about man-made pollution or the human activities which are causing pollution. So the extent of pollution, industry has a major role. Now, depending on, there are various types of industries. Say, for example, uh, if you talk about paper which you are using, then obviously there will be a industry behind it, which is pulp and paper industry, where paper is made from the wood, right? So wood is cut and later it is transformed into the final product, which is paper. Then whatever you are eating, it also has, for example, uh, um, sugar. So sugar, for that also sugar is manufactured from sugar cane. Okay, so that also has a separate industry. So depending on uh, whatever you see around, there is an industry which is related to it, and it causes some emissions. There could be some gases which are emitting, there could be some wastewater streams. Obviously, there are equipments involved. There are and these equipments, they like, even if you take example of your house, then if you turn on the mixer grinder that you are using, it creates a lot of noise, right? So if you talk about industrial scale, then such sort of noise which equipments will make, that will be much higher as compared to um, the household noise pollution which is there. So industry, they have the tendency to create pollution at much larger extents, and depending on the type of industry, may it be pulp and paper industry, may it be some pharmaceutical industry, the composition of the gas stream, the wastewater streams which are generated, they all will be different. So we have classified industries based on uh, the pollution it creates usually. So the classification is generally, first is the red red classified into red categories, where the industries which has the tendency to create highest amount of pollution. Okay, so pulp and paper industry, steel industry, they all come into the category of red. So these industries they create maximum pollution. Then comes orange industries. The pollution create is somewhat lower than red category, and last is the green, which has the least pollution generation. Now, depending on the type of industries, the pollution control boards, because we obviously our aim is to control the pollution so that minimum impact on environment is observed, minimum health hazards are observed, okay, and we have a better place to live. So for that, there are central pollution control boards, there are state pollution control boards, and those pollution control boards they impart some laws for the discharge of pollutants in the environment. And depending on the category of industries, there are different norms specific to the industries as well. So if you want to look more into it, you can even go to the website of CPCB and you can find some specific standards also. Uh, like for example, there will be some specific standard for release of carbon dioxide, carbon monoxide for different types of industries also. So now, do you have any doubt so far? Okay, so if not, let's move forward. Uh, Next, we will see once the pollution enters, what could be the possible impacts of those pollution. So first, if we talk about water pollution, then we have discussed earlier also there could be some physical, chemical, or microbiological pollution which can be there in water or which can cause pollution. So there could be some different impacts. For example, DO is dissolved oxygen. So water has its inbuilt dissolved oxygen concentration, and that oxygen is used up by the aquatic organisms which are present in the water bodies. So uh, this dissolved oxygen is usually recommended to have 8 to 9 ppm of dissolved oxygen concentration. Now, if there is some water stream which has organic contaminants and it flows through or it enters the water bodies, which is causing pollution, then what happens is that organic matter, it has the tendency like CXHY, right? So it has the tendency to use up the oxygen to get converted to carbon dioxide and water. Like these are the end products. There could be some intermediate products also. So what it does is it takes up the water which is present, it takes up the oxygen which is present in the form of dissolved oxygen. Okay, so let's say this is the dissolved oxygen concentration which is ideal. Now there is some BOD which enters into that water stream. So now that BOD consumes the oxygen which is already present in the water stream and it will get converted into some final product. So what it will do, BOD obviously will fall, but there will be a depletion in the dissolved oxygen concentration also. Now, obviously, if the dissolved oxygen concentration decreases, there will be difficult in respiration for the aquatic organisms, and obviously there could be some death of fishes also observed. Now, obviously, this BOD it will reduce, but at the same time, due to the oxygen which is present in the atmosphere, there will be re-aeration also. So there will be a balance after some time. So this sag curve is observed, and this is nothing but known as oxygen sag curve, which is caused due to the entrance of some pollutants or organic pollutants in the water bodies. Now, there could be some other type of pollutants which cannot have impact on oxygen content. Say, for example, arsenic contamination, which can cause cancer, which can affect your skin. There could be some fluoride contamination, which can cause some impact on your teeth, which was earlier we had discussed. It can cause fluorosis. It can have damage to your bone. It can make your bones brittle. Now, next, there could be some excessive nitrates or nitrogen concentration. Now, nitrogen, it is an important component of fertilizer, right? You would have heard of NPK fertilizer, where N stands for nitrogen. Now, nitrogen is a nutrient for fertilizer for plants to grow, which we supply from fertilizer. Now, if there is excessive nitrogen available in water, what it does, there will be some excessive growth of plants in the form of some algae or seaweed. Okay, so there will be some excessive growth of plants, and what happens is it can block uh, the sun entrance of the sunlight. It can block the sunlight entrance. Okay, and it can block, it can, what we can say, it will hamper the growth of other living organisms. So it will cause eutrophication, which will again be harmful. So all these dissolved oxygen depletion because of organic contamination in water bodies, some chemical or biological contamination, it impacts uh, it impacts water and its quality. And if we consume such water, we will also have some hazardous impacts. Now, if we talk about air pollution impacts, now air, as I discussed in the previous slide, it can have particulate matter and it can have some various gaseous contaminants in the form of carbon monoxide, dioxide, various SOx, NOx, right? So, what it does, there could be asthma. There could be, like, for example, if NOx is present, then it has the tendency to react further with some of the uh, other contaminants which are present in air. So there could be some fog formation which can cause visual impairment. So you will not be able to see far distances. Right? Aesthetic damage, which I talked about, the deposition on the marble of Taj Mahal. There could be some plant damage as well. So, such sort of impacts due to air pollution can be easily observed. Now, if we talk about soil pollution, then it could be because of some agriculture runoff. Then it could be because of some poor management and disposal of waste. And obviously, we have seen that how this soil pollution, once it is caused, it will further pass on through the food chain and it will cause some uh, unavoidable uh, damage to human health, unavoidable diseases, right? And now, if we talk about noise pollution impacts, then obviously, if I make so much noise, then sitting for a longer time, it can cause you headache, right? So noise pollution is not just that. So industries where it has equipments which is making lot of noise, then it can first start with annoyance, like you will be annoyed, you can have headache, then later you can have some loss of hearing, then your performance may get affected because of the sleeplessness. It can cause your concentration to get affected, right? So, those all impacts due to noise pollution you can observe. And lastly, due to pollution, due to the increase in the carbon dioxide concentration, there is global warming which is caused. Further, ozone layer is depletion because CFCs, which are chlorofluorocarbons, which were used in the refrigerators. Now those are emitted in the atmosphere. Now once they are emitted, it has the tendency to react with the ozone layer. Okay, so Earth has, if this is Earth, it has this ozone layer which protects us from the UV radiation which is coming from the sun. Now, this CFC, it rises in the atmosphere and it has tendency to react with this ozone, and that is why we have heard of ozone layer depletion because there is a hole which is created by the reaction of the CFC and ozone. So, ozone concentration reduces, and which is called ozone layer depletion. So, further, this creates the UV light to penetrate in the Earth's atmosphere, which was earlier blocked by the ozone layer. Okay, so that can further cause various damage. For example, UV light has the tendency to cause even cancer to human beings. It can cause skin cancer, right? So all these factors which are coming up day by day, it has different adverse impacts. Now, one more terminology which was talked in the class was nitrate pollution, which is caused in water. So, if nitrates they enter water bodies, and if we consume such water, then obviously it causes uh, blue baby syndrome. You would have heard. Okay. Then again, if we consume carbon monoxide, then what happens? Then there are some different, uh, you know, the oxygen level in our body, it gets affected because the hemoglobin oxygen carrying capacity of blood gets affected by the presence of nitrates, by the presence of carbon monoxide in the body. So, if we consume such water which is affected by nitrates, if we consume water which is polluted by carbon monoxide, then what happens? It has the tendency, for example, carbon monoxide, if it is present, if we inhale such air, then it has the tendency to react with hemoglobin, and later this carboxyhemoglobin, the oxygen carrying capacity of such hemoglobin, it reduces. So in that case, we need to know what is the carbon monoxide we are inhaling and what sort of damage it can occur. So there is a relation by which we can measure how much carbon monoxide is present in our body and how much saturation can be, uh, like how much carbon monoxide has reacted with hemoglobin to form this saturated compound, right? So that indirectly it relates into uh, lesser oxygen in our body, so which we can relate later to how adverse impact it can have. Okay, so it depends on how long we have been exposed to such air. What is obviously its concentration, because more the concentration, higher will be the chance of uh, adverse impact, right? So numerical we will solve in this class depending on this formula as well. So is it clear so far? Yes, Sainika, I request to please be interactive so that you will also get to know, and maybe it will be easier for a class. So let's move forward. Now we have, so far we have seen that this pollutants, once they enter, it can cause harmful impacts and what sort of harmful impacts it can have, right? So now we need to see how these pollutants, if they enter into maybe air or water, how they are transmitted, and if transmittance is in one, like what pattern of transmittance or what factors uh, cause mm, what you can say uh, dilution of the pollution so that its impacts can be minimized, and what factors it will promote pollution to uh, be more concentrated and it will have more impacts. Yes, Bhavya.
Ma'am, I had a question that there is a variable y which says distance from center line of the plume. The slide which you were explaining right now.
Hmm.
So horizontal distance from center line means that is it in, I mean,
So
XY plane? I mean,
you have to imagine we are coming to that point actually. I just have started this slide. Basically you have to imagine three directionally in three dimensions. So X is this direction, okay. So and Z is the upward direction. So Y direction is um, you can say towards you. Like if you are facing the screen, then it will be towards you. Whatever, like let's say the screen is the center point and you are sitting after some distance. So that distance you can say it is the y direction.
okay, understood, ma'am.
Okay. Okay, so here if we talk about air pollution, so if some gaseous pollutant it enters or some particulate matters as well, if it enters into the air, then there could be transfer of that pollution into the atmosphere due to various ways. For example, it could be diffusion. For example, if this is the point from which it is emitting, right? So here it is having concentration C1, but like from certain distance, like if this is the center line, then at some point there will be no such, like it will have zero concentration or it can have some concentration. Say for example, this is the vehicular emission and it is emitting carbon monoxide, and here is your home, which does not generate carbon monoxide. So you can say carbon monoxide concentration here is zero. So obviously you would have heard of a term called concentration gradient, or you can say gradient. So gradient here is due to concentration because concentration from where it is generated, it is much more as compared to some point which is at a distance, let's say x. So here the whatever transfer happens due to this sort of concentration gradient is nothing but termed as diffusion. So external factors does not play any role. Now there could be some uh, wind effects also. Say for example, you are moving your vehicle is in this direction. So exhaust carbon monoxide will be going in this direction. Now, if wind is moving also on in this direction, then it will have carbon dioxide more, like it will travel more with the wind because wind will move faster. Wind will have some velocity which will further promote the travel of this carbon monoxide, right? So that is nothing but known as advection. So advection, it depends on the strength of wind and its direction. So say for example, if its direction is reverse or it has some normal direction, then its spread will be affected. Okay. Now here why we need to learn the travel, like in what direction the pollution is traveling, because say for example, if this is a chimney, and from this, the pollution, like there is a gaseous stream which is emitted. Now, wind, if if the wind is traveling such that the pollution it goes upwards, then the chances such that here we it will travel upwards, and here we are present on the ground. So since it is not traveling downwards, we are not impacted by its presence, right? Even though it is contaminating, it is further polluting, it can cause some further damage in the upper layers of atmosphere, but here our health is not having immediate impact, right? So we need to learn how the air is traveling in the atmosphere, whether it is coming into our contacts or not. So if it is not coming in contact, directly we are not getting impacted. So for that we need to understand one terminology which is atmospheric stability, where it is the measure of air's tendency to resist vertical air motion. Okay, so unstable, stable, and neutral are three different stability of atmosphere. Where in one case, uh, there will be a lot of vertical motion. Then stable is it will not promote the vertical motion, and neutral means it has like it stays there also there only. Like it will neither promote upward, neither nor it will demote the upward motion. Now, this upward motion of air, it can be affected by the temperature of the air and obviously the temperature of the emitted air stream as well. So, temperature gradient. Obviously, so if this is the Earth's surface, as you move upward, there will be some decrease in the temperature of air, and that is nothing but not known as environmental lapse rate. So that rate at which the temperature changes, it is known as lapse rate. Now, this lapse rate also, for example, the air which is warmer as compared to the environment, it will have the tendency to rise upwards. So depending on what temperature it exists, how at the rate at which temperature changes across this environment, it will also affect how fast the pollution will travel, in what direction it will travel, right? So depending on that, there could be some different patterns in which this pollution which is generated, it can have different patterns in which it will travel in the atmosphere. So usually what we assume is if there is a stack or the chimney from which it is the pollution is generated and it travels. So here let's say after some distance x in this direction, and z is the vertical direction. So it is assumed that if this is the center line, then there will be a concentration which will be followed in a Gaussian, like this bell-shaped model is nothing but Gaussian model. So it follows it. So as we move away from the center line in both plus z direction and minus z direction, the concentration reduces in a bell-shaped uh, uh, manner, right? So it depends on, like after a certain distance, it depends on what concentration it is emitting, at what rate it is emitting, obviously the wind speed and the direction, and further like if we take all these factors into account, then this is the model which governs the concentration at a certain distance, say for example this c at any point xy. Okay, why I have already explained just few minutes back. So at any point, this will be the equation which will determine the concentration. So units you need to maintain the consistency. Now here the height which is taken into account, it is two heights. One is the effective height, which is the stake height plus there will be a center line with which from which we are considering the concentration to be calculated. So this delta H, if it is added to the stake height, then it is uh, known as, yeah, sorry, it is known as effective stake height, right? So for delta H, uh, how much the plume rises, which will be added to the stake height to calculate effective stake height. It depends on the stake flue gas velocity, the exit diameter, obviously, the wind speed, and the exit outlet pressure. Okay, so the pressure at which the exit is happening and the outside pressure, because also that will create a gradient and it will affect the flow. Obviously, another gradient could be temperature gradient, right? So depending on that, by this factor, you can calculate how much will be the spread of that plume. And based on that, you can have a calculation of effective stake height. Now that was all about how uh, uh, the pollution travels or it transmits into the air, and lesser the chances of coming in contact. Like through this models we are able to predict the concentration. Okay, so let's say this is the emission point, and after a certain distance here we are standing. Okay, so at some height and at some distance, so if the concentration which we are coming into contact, we are able to calculate, if that is lesser than the permissible limit, then the chances of getting affected or getting adverse impact will be much low. So that is the physical interpretation or the significance of this model, like how much we are coming in contact or what is the concentration we are coming in contact, and whether this concentration we are coming in contact it will have adverse impact or not. So that is its significance. So similar to air, now we will have how the pollution it transmits into water bodies. Say for example, here we are taking into account aquifer example. The aquifer is nothing but water which is a body of rock and sediment which holds groundwater. Okay, so under the surface, whatever the soil and rocks and sediments they are present, there will be water which will be stored along with that, and that is nothing but known as the entire aquifer. Now, water which travels through that aquifer, uh, um it so the water flow through that aquifer, it has its flow which will be governed by Darcy's law. So this model it is used to predict the flow of liquid, and here which is water, into a porous medium, and here the porous medium is nothing but rocks, sediments, and porous solid. So depending on the velocity through at which the groundwater it is percolating or it is passing through the soil, depending on that, it will have the transmittance or transmission of contaminants through that groundwater and further to the soil as well. So that groundwater Darcy velocity is nothing but calculated as, this is hydraulic coefficient. This is the gradient. For example, water is flowing from one point which is 1 and 2.2, and it is having some gradient. So it will flow from higher point to lower point, from higher altitude or not altitude, from higher height to lower height. So that gradient is nothing but hydraulic gradient. So depending on that difference in the height, it will travel, and that is nothing but H2 minus H1. per unit distance. Okay, so that is Darcy velocity. Now, further, the pollution which is traveling through that water body, there are chances that the contaminant tends to react with the porous media through adsorption or through some precipitation. So, in that way, the chemicals, the concentration further, uh, like for example, some precipitation occurs or some adsorption occurs, and that is why the concentration reduces. Okay, so that causes the concentration reduction over the length of the aquifer, and that is termed as chemical retardation. Now, chemical retardation, it uh, depends on the contaminant. It is defined as the ratio of contaminant concentration in the aquifer and to the contaminant in groundwater. So obviously that depends on the velocities, which is defined as the ratio of velocity. Now,
Hello, ma'am.
yes,
Sorry to interrupt. I just want to ask what K is the Darcy's constant.
yeah.
What does Darcy's constant depend upon? I mean, is it specific to material or, I mean, can you please elaborate on that?
Sorry, your voice was a bit.
I'm saying the Darcy's constant. What does Darcy's constant depend upon? For example, I think we learned in CRE that the chemical reaction constant depends upon temperature or some specific things. It could depend upon pH also sometimes. So, is Darcy's constant also dependent upon something else, or is it a constant visible to material
It
or
is. It depends on the porous medium through which, for example, different material has different permeability depending on the porosity and the characteristics. Okay, so it depends. It is a kind of, I guess, it is a kind of permeability constant. How, like, how much permeation it can allow. So it is, I guess, that constant which governs. The permeability of water, like more the permeability, more will be the velocity, right? So it depends
Hmm.
on the
So
porosity, it
that means
depends on how compact or how the rocks are arranged, how the sediments are arranged. So
basically the
it depends on,
porosity.
yeah, it depends on the structure, it depends on the arrangement. Yeah, yeah, you are correct. It depends on the permeability. Like it is a sort of permeability, how much it is able to allow the water to pass through it. So more it
Okay.
allows, more will be the velocity, right?
Okay. Okay. Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Okay, thank you. Uh, Um, I'm not going much detail of this derivation. So next, what was taught in the class was dissolved oxygen concentration. Like here in the previous slide, we have learned that there is a chance that dissolved oxygen concentration it decreases. So there was a derivation which was made on what different equations were derived for calculation of dissolved oxygen concentration. And also um, if you like there is a biological like BOD uh, entrance point. If BOD enters into water body, so after traveling to some point or after a certain distance, what will be the dissolved oxygen concentration. So such calculations have been the equations which govern that calculation, that has been derived. So you can look into it, and if you have some uh, confusion in it, or you have some confusion in the numerical, you can discuss it. So that's it for the brief of the classes. Now let's move to the assignment for this week. So this is the first question, where geogenic arsenic in groundwater is an example of which sort of pollution. So you have to choose the best option. So here geogenic arsenic is nothing but it is related to naturally occurring. So it is a class of natural pollution. So A is the correct answer. Next is the pollutants which remain intact when released in the environment because they do not break down by natural processes are termed as dash. So, the pollutants here, the key term that you need to look into is they do not break down. Okay, so they are not impacted by the external factors. There could be some natural processes, so they are not impacted. So, those class of pollutants are known as persistent pollutants, which they do not get impacted by external factors and they remain in its original form. So, A is the correct answer again. Next question is anions such as F minus, Cl minus in wastewater, they are characterized as dash. So these are the class of chemical pollutants because these are anions and they are some sort of like chemicals. They are not adding up to some visual change or some like what you can feel, right? And they are obviously not some bacteria or microorganisms. So they are chemical pollutants. Next is the wastewater from pulp and paper industry contains mainly dash. So here, correct answer is A, soap and lignin. Now, why lignin is a major component in wastewater from pulp and paper industry? Because you are using wood to form final product which is paper. Now how wood is converted into paper? So for that wood is firstly digested. Okay, so wood has major three components. One is cellulose, hemicellulose, and last is lignin. So so you will have to segregate all these three components and paper like you are extracting cellulose. So lignin is not required in paper formation. So like that will not be further that will not be used further. So major component which is a byproduct of wood digestion is lignin. Okay, and obviously it is not easily digested also. It is not degraded also easily. So that stays in water and it is obviously a major component in wastewater from which is coming from pulp and paper industry. So since we are using wood and having lignin as the major component in wood, lignin is the major component in wastewater as well. Now next question is which of the following sector has highest contribution to particulate matter 2.5 micron emission to air? So the correct answer is transport here. Next is the skeletal disease in the following picture is caused by the long-term exposure or consumption of which of the following contaminated water. So we have understood that there could be some adverse impacts to our various body organs due to various chemicals and even microorganisms. So here, if we talk about some chemicals which can cause some bone, like which can damage our skeletal, uh, or which can have damage to our bones, which is due to the excessive fluoride contamination. So it has the tendency to even make the bones brittle in nature. So why that is happening? because excessive fluorine it can cause fluorapatite formation. Okay, so that is having some different you know uh, um, uh, like more the fluorine, more will be the fluorapatite, and it can have some different uh, way, like bone will have different like its characteristics, I can say its characteristics will change. So that is why um, you you can have such disease, like bones will be totally like damaged. So next question is the ratio of total contaminant with contaminant and unit volume of aquifer to the contaminant dissolved in groundwater. So that is a direct definition which we have discussed in previous slides. This is nothing but retardation factor. Now, what is again a retardation factor? Which is nothing but uh, due to the deposition of like it is the reduction in the concentration which could be because of certain precipitation or absorption of uh, chemical chemicals or pollutants which are present, and the factor that governs that reduction, that is nothing but retardation factor. Now next is match the following. uh, Here you have TDS, which is the dissolved solids. Now that adds up to physical characteristics. Okay, so for P it is 2. Then we have hardness. Now hardness is obviously due to the presence of calcium and magnesium salts in the form of carbonates, in the form of chlorides, sulfates. So these are nothing but chemicals which are present. So that is corresponding to the chemical characteristics, right? And prions, they are microbial or microbiological characteristics. So for this, the correct answer is P2, Q3, and R1. Next question is a numerical. So here you need to calculate air to fuel ratio which will be required for complete combustion of a liquid fuel in an internal combustion engine. Now here there are multiple catch that you need to look into. So first, this M to M ratio is nothing but mass of air per unit mass of fuel you need to calculate. Okay. Next is for what combustion, which is complete combustion. Now complete combustion means whatever the carbon is present, it will get converted to carbon dioxide. There will not be converted to carbon monoxide. So this, if carbon monoxide is present, then it is partial combustion. This conversion is complete combustion. So we need to have conversion from C6H13 to CO2 and H2O. So this reaction is complete combustion. Obviously, we require oxygen for this, and this oxygen is supplied by air. Okay. Now, air. Okay. So let's first balance this equation. So our aim is to find out air to fuel ratio. So what is happening? We are combusting this fuel to carbon dioxide by supplying oxygen through air, and air has nitrogen and oxygen both, and other inerts and some other chemicals also, but majorly these two components. So this air which will be required to completely combust this C6H13 to CO2, so that ratio we need to find out. So firstly, we need to find out how much oxygen is required for complete combustion of this fuel. And based on that, we can later calculate how much amount of air will be required. And then we can take the ratio of both. Like for how much amount of air will be required for 1 kg maybe for combustion. So here there are 6 atoms of carbon. So 6 carbon dioxide molecules will be formed. Now hydrogen in the fuel is present as 13 atoms. Now here since it is 2, so 13 by 2 molecules of water will be formed. Now carbon and hydrogen they are balanced, but we need to balance oxygen. So on the right hand side, the amount atoms which are present is 6 into 2, 12 atoms of carbon oxygen in carbon dioxide and 13 by 2 in water. Okay. Now if we add up, so it is nothing but this 13 by 2 is 6.5. Okay. So 12 plus 6.5 is 18.5. So 18.5 total atoms are there. And here, if we look on the LHS, then each molecule has 2 atoms. So it will be 18.5 by 2 of oxygen molecule. So these are the number of moles will be required. Okay, so for 1 mole of fuel, you require 18.5 by 2 moles of O2, right? Now for this much moles of O2, we need air to be supplied. Okay, so 1 mole of air has 21, okay, sorry, 100 moles of air has 21 moles of O2. Now for our reaction to happen, 18.5 moles, sorry, 18.5 by 2 moles of oxygen are required for complete combustion. So how much moles of air you will supply? You can cross multiply this. So it will be, let's say this is x. So x equals to 18.5 by 2 into 100 divided by 21. So if you calculate this, um, it will be, let me write 18.5 by 2 into 100 divided by 21. So it is coming out as 44.05 moles of air will be required. Okay. So now that to take the ratio of mass of air divided by mass of fuel. So for that you know that 1 mole of fuel requires 44 moles of air. Okay. So 1 mole into molecular weight of air because mass equals to moles into molecular weight. So 1 mole of, sorry, moles of air are 44.05 moles of air into its molecular weight divided by 1 mole of fuel which is taken into molecular weight of fuel. Now what is the molecular weight of air? You can obviously calculate, but right now if I say then it is 29, you can like it is 28 point something, but you can round it off and take 29 as 29 gram per mole of, it is the molecular weight of air. And for fuel, let's calculate, it is 6 cross 12, which is the molecular atomic weight of carbon, plus 13 into 1, which is the atomic weight of hydrogen. So if you do that calculation, it should come out to you as 6 cross 12 plus 13 as 85. Okay, which is the molecular weight of C6H13 fuel. Now, if you substitute these values, uh, fuel air to fuel ratio should come out to you as 44.05 cross 29 divided by 85. So do this calculation. It should come out it is coming to me as 15.01. Like the nearest answer in this in the options is 14.8. So you can say 14.8 is the ratio which is required for and this ratio you can like elaborate as 14.8 gram of air or kg of air required. Like if we are taking gram as the unit per gram of fuel. Okay, so 14.8 gram air required for 1 gram of fuel to be completely combusted. I hope it is clear. Yes, Sainika. Okay, so let's move forward. And this is the last question. Here, carbon dioxide is emitting from 75-meter high industrial chimney of diameter 0.25 meter to the atmosphere. And so here there is a chimney. It has height of 75 meters, and this diameter is given to you as 0.25 to the atmosphere, which is having pressure of 1 bar. Okay, on a clear summer day. Now, wind speed at 10-meter height from the ground is 3.8 meter per second. Okay, and calculate the effective stake height. Assume B category stability uh, with P value equals to 0.15 and stacked gas velocity is 7.5 meter per second. Temperature of stacked gas and ambient air at 80 meter height is given to you as 50 and 25 degree. So here, this is the formula which you need to use. So what all data you require first, let's see whether they are all are given to you or not. So stack flue gas velocity you require. So that is given to you, right? Vs is 7.5. D is the stake diameter at exit. So that is also given. D equals to 0.25 meters. Next is U is the wind speed. Now that speed is at 10 meters height. And this speed which is required, it has to be at the take height. Okay, so for that you need to use this correlation where P is the value which is this already given. Okay, P is given to you is 0.15 depending on the air stability. Then P is the outlet atmospheric pressure which is given to you as 1 bar. So 1 bar is given. Now this bar is not the pressure unit. You need to use kilopascal as the unit. So 1 bar is 10 to the power 5 pascals. Okay. So in kilopascals, it will be 100 kilopascals. Okay. So that is nothing but 100 kilopascals. And next is T stack temperature flue gas is given to you as 50 degree. If you convert it in Kelvin, it will be 50 plus 273 Kelvin. And for ambient air, it is 25 degree, which will be 25 plus 273 Kelvin. Now, you just need to substitute all the values and everything will be calculated. So let's first calculate uh, velocity, wind speed at the stake height. Okay, so for that, U equals to 3.8 into 75 by 10. power 0.15. So this should come out to you as 75 by 10, okay, power 0.15 into 3.8. So it is coming to me as 5.14 meter per second. Sorry. Now if you substitute all the values, delta H equals to Vs is 7.5 divided by, sorry, D, sorry, U which is 5.14 into D which is 0.25 into 1.5 plus 2.68 plus 10 to the power minus 2 into 100 into in the numerator plus this will get cancelled out. So it will be 25 remaining divided by 25 plus 273 into 0.25. So if you solve this, the answer should come out to you as the A 75.56 meters. I guess you can calculate this. I hope it is clear now. So that's it for the assignment part. Now, if you want, we can have a brief look into the numericals which are solved by the professor in the form of tutorial. So first problem is a confined aquifer which is 225-meter thick has two monitoring well spaced 600 meters apart. So point 1, point 2, they both are 600 meters apart. So that is nothing but L along the direction of groundwater flow. So this is the direction of flow, let's say, and the difference in the height of these two wells is 3 meters. So H2 minus H1 is given to you as 3 meters. Now the hydraulic conductivity K is 50 meter per day, right? And estimate the rate of flow per meter of distance perpendicular to the flow. So here you need to calculate the flow rate, and for that, what is the formula? Q equals to K A dH by dL. Now dH is nothing but 3 meters. dL is, since they are 600 meters apart, so it is 600. K is given to you is 50. Now area you need to calculate. So area is nothing but the area through which, or is it's the cross sectional area through which it is flowing. So here you are given 25 meter thick, okay, but other dimension is not given. So let's say the width is, you can assume obviously it is 1 meter. So if you put up all the values, then the flow rate through that width is nothing but 6.25 meter cube per day. Okay. Next question is a phosphorus limited lake with surface area equal to 90 into 10 to the power 6 meter square is fed by 18 meter cube per second stream that had a phosphorus concentration of 0.01 milligrams per liter. Now, in addition, effluent from a point source adds zero point 0.9 gram per second of phosphorus, and the phosphorus settling rate is estimated as 10 meter per year. So the settling rate is nothing but phosphorus rock deposition, which results into 10 meters of deposition in a year. Now estimate the average total phosphorus concentration and what rate of phosphorus removal in wastewater treatment plant would be required to keep the concentration of phosphorus in the lake at an acceptable level. Okay, so here uh, this is the lake, let's say, and there is a stream. the area of which is it is given, and there is a flow rate of stream which is given to you 18 meter cube per second, and further the effluent enters which has phosphorus contamination or phosphorus addition rate as zero point 0.9 gram per second. So you need to find out the average concentration, and here it is 0.01 milligram per liter. Now, since this is flowing, the concentration will increase. So, first let's find out what is the inlet flow rate, or what amount is coming in. So, so phosphorus loading from the incoming stream. Okay, so if a stream is coming at the flow rate of this, and it has concentration C in zero point zero 0.01, so it is adding phosphorus at a concentration of 0.18 gram per second, and another wastewater stream which is adding at zero point 0.9 gram per second. So if you add up those, it will be 1.08 is the amount of phosphorus which is adding into the lake. Now, obviously, there will be some flow. So, and apart from that, there is a settling. So, to account for settling, settling is given to you as 10 meters per year for phosphorus. So, if you want to have uniformity in the units, so convert this year into seconds. So, 1 year has 365 days. Now, 1 day has 24 hours. 1 hour has 60 minutes, and 60 minutes has 60 seconds. So, this is the conversion, right, from year to second. So, this will be the settling rate in meter per second. So, now to find out concentration which is remaining, uh, so total addition rate, it will be divided by what is the accumulation. Okay, so for that it is nothing but q plus bs into a, and so the concentration in the lake which is coming, which is the remaining concentration, it is nothing but 0.023 milligram per liter. So that is obviously higher than what is acceptable, which is 0.01. Now, to limit the concentration to 0.01, which is the acceptable limit, so by using this equation only, you can find out what should be this S, addition rate, okay, by substituting C here as 0.01. So addition rate, if it is lower than 0.29 gram per second, then obviously the phosphorus need is within the acceptable level. Next question is um, CO2 is emitting from 80-meter high industrial chimney of this dia. Okay, so this question is similar to what we have solved in the assignment. It's just that there is a difference in the height. Okay, so you can just change the height in that question, and later you can like there will be just difference in the final effective stake height. Okay. So just wind velocity will be affected. Rest all the values are same. So you can just do that substitution and calculate. I'm skipping this question. Next question is a 915 megawatt power plant with an efficiency of 40% uses coal as a fuel source. Now the coal has 1% sulfur content and a calorific value of 30 megajoule per kg. Now the effective stake height is 520 meter. And if neutral conditions prevail, find out the maximum ground level concentration of SO2 at 10 and 100 kilometers from the plant. Assume U10 and atomic weight are given. Exponent of velocity p is given to you. Further, the probabilities are given. Okay, so let's solve this question. Let's first understand. Okay, so here you are burning coal which has in a power plant which has 40% efficiency and you are generating 915 megawatts. Okay, so power generation is required is 950 megawatt, which is 915 into 10 to the power 6. Mega is 6 into the power 6. Watt is nothing but 1 joule per second. So this much amount of energy you are generating. Now, so if you convert it in per hour, sorry, so it is nothing but you convert this second into um, so 1 hour has 3600 seconds. So 1 second is 1 by 1 3600 second hour. So do that. Okay. So you will have this much megajoules per hour. So for this much amount of energy generation, since it has 0.4% efficiency, uh, let's say 30 megajoules is produced by 1 kg of coal. So how much will be required to produce this much amount of energy, right? So you just cross multiply it, and further it has 0.4 40% only the efficiency, so you need to divide by zero point 0.4. Okay, so more coal will be required. So this much coal is required. Now uh, this much coal is required, and it is mentioned that 1% sulfur content is there in that coal. So this is tons. Okay, so 1% of this much is what you can say, that is the sulfur which is present in the coal. Now that sulfur is converted into SO2, and if you want to find out the weight of SO2 which is produced, then 32 gram of sulfur it will form 32 plus 32 64 grams of sulfur dioxide. So if you want to find out amount of sulfur dioxide present, you need to multiply with 6. Like for example, if this is the sulfur amount, so it 64 has 32, then if this is 274.5 tons per hour, then how much will be the SO2? So 274 into 64 by 32 into zero point 0.01, because zero point 0.01 times it is there. Next is you need to find out, uh, like you have known the emission rate, okay, which is in kg per second, because that is required. Now else everything you know, which is SY, SZ, they are given to you. Wind speed you know, it is given, right? Yeah, which is at 10 meters height. So that again you need to calculate at 520 meters by this formula, and Y and X are given to you. So if you put up all the values, Y is 0 in this case, I guess. No, see this. X is given, and since Y is not given, you can take it as 0. And yeah, Y is not given. So consider it as the center line for the Y, and you can calculate the C value. Next question is a coal-fired power plant converts one third of the coal energy into electrical energy. The electrical output of this plant is 500 megawatt. So, which means that electrical output is 500 megawatt. So, the energy input energy, because one third is the only output, so input energy is nothing but 3 cross 500, which is 1500 megawatt. Now, in this plant, only one third of the coal's energy is converted to electrical energy, which we have already found out what is the amount of energy which is provided, and 90% of the rest energy. So, rest energy which is remaining is 1500 is the input minus 500 is equals to 1000 megawatt is the remaining energy. So, 90% of that energy is rejected to river through using cooling water drawn by nearby river and recycling back into the river. So river has upstream flow of 75 meter cube per second. So the amount of energy rejected to river is 900 megawatt. So what you need to do is the river has the temperature of 20 degrees Celsius, and if the cooling water temperature rises by 5 degrees Celsius, what flow of cooling water stream is required? So cooling water flow required is, so specific heat to you is given. For example, 1 kg. So for 1 kg per degree rise in temperature, it requires 4184 joules. Okay. So here there is 5 degrees rise. So for 5 degrees rise, the amount of energy that will be consumed is this much. Okay. Um, and that is per kg. So this much amount of energy it can take up per kg. So now if you want to have this much energy to be consumed, so for 1 kg it will be 4184 into 5. So if you want to have 900 into 10 to the power 6 joules of energy to be consumed per second. So how much will be the kgs required? Kgs, you know, uh, required. So cross multiply this. So this will come out to you as answer. And if you convert it into meter cube per second, so that you can do it by density because it is having 1000 kg per meter cube. So divided by 1000, which will come out to you as 43.01 meter cube per second. Now increase in the river temperature is nothing but if you are supplying same heat directly to the river, which is having a flow of 75 meter cube. So again it will be 2 degrees, and so the final temperature is, if you add up to 20, so it will be 22.87. Next question is determine the hemoglobin concentration as percentage saturation of CO concentration of 1200 ppm after 0.5 hours of exposure. So here you are given that you are exposed to 1200 ppm of carbon monoxide concentration for 0.5 hours. So directly there is a formula where carbon monoxide will be converted to carboxyhemoglobin and how much percentage saturation will be obtained after zero point 0.5 hours that you need to find out. So beta is 0.15 per ppm of 0.5%, 0.15% saturation per ppm of CO, and for exposure for zero point 0.5 hours, gamma is 0.402, which is constant. You just need to put up the values. So 0.15 into 1 minus exponential of minus 0.402 into zero point 0.5 hours of exposure into 1200. So the answer should come out to be as 32.78% saturation. Next question is further determine the minimum time for 80% saturation. Right? So within zero point 0.5 hours, it is getting saturated 32% or 33% almost. Now here you need to find out T where you are given this. So you just need to do opposite. Okay, you have all the values you can put up and solve for it. The answer should be 1.46 hours. Next question is the, oh, this also we have solved in the assignment. So that's it from my side today. I hope it is the, do you have any doubt? I hope it is clear to you all. Yeah, so if you have no more doubts, I can end this class. Thank you all for joining. I will end this meeting. We will meet in the next class next Tuesday, same time, 7 to 9. Thank you everyone for joining. I'm ending this meeting. Thank you.